This is the second half of the video for section 3.2, and it deals with inverse trig functions. Now this is a section where a lot of students get confused, primarily because of the notation. One thing to keep in mind, we've talked about reciprocal functions. These are not the same thing as an inverse function. Since trig functions are ratios, are fractions to begin with, the reciprocal just simply means that you flip the ratio over. The inverse, on the other hand, is when you are trying to find the angle given the trig ratio. So this is working backwards. So far we've been given an angle and we want to find the trig ratio, that fraction or decimal. What happens if you have that ratio, you've gone out and measured two of the sides of the triangle, and you want to work backwards and find that angle? This is where the inverse trig functions come into play. This is not reciprocal functions. Inverse and reciprocal are not the same thing. A reciprocal is a type of inverse, but there are multiple types of inverses. You've dealt with them along the way. Subtraction is the inverse to addition. Division is the inverse to multiplication. Square root is the inverse to squaring. You've dealt with all of these inverses in the past, and now we are learning another one. It's just that the notation in this case, which you can see here, is going to have that -1 exponent. Since the -1 is on a function sign and not a number, it means that it is an inverse. When the -1 exponent is on a number, it means it's a reciprocal. So since it's on a function sign, it means inverse. So one thing to keep in mind for this chapter, we're only going to deal with angles between 0 and 90. We'll talk about angles greater than 90, between 90 and 360 in the next chapter. So if, for instance, we want to find the angle theta, and we are told that the ratio for sine of theta is 0.4321, then in our calculator, we would type in sine inverse. So we would hit second and then sine to get our sine inverse, and we would type in 0.4321. And we would hit enter, and this tells us that our angle was 25.6 degrees. So you see that here, 25.6 degrees. So in order to find an angle, we use inverse operations, inverse trig functions, on the given ratio, decimal, fraction, whatever we're given, to find an angle. So suppose we want to find theta when cosine is 0.1463. We want to round to the nearest tenth of a degree. So in this case, theta is going to be the inverse of cosine is cosine inverse, and this is 0.1463. Now something to point out real quick before we go to the calculator is that this textbook actually uses some of the older notation as well, which is the arc cosine. So once in a while you may see them use this instead, arc cosine of 0.1463. And in this case it was a little less confusing because it looks like a different function now and it doesn't have that -1 exponent. But typically in your calculator it's going to be listed the first way as cosine inverse. So again, if we go to our calculator, we hit second cosine to get our cosine inverse, and then we do 0.1463. And we end up with 81.6, approximately 81.6 degrees. Now I want you to take a second, pause the video, and try example 19. So for this we should have found tan inverse of 0.4684, which comes out to be approximately 25.1 degrees. Again, very close to the problem that we had before. So in this case, our angle that would give us the ratio 0.4684 was 25.1 degrees. Now, putting the inverse and the reciprocal trig functions together can get even more complicated, and like I said, they are not the same thing. So we need to make sure that we pay attention to both pieces of this. If we want to, for instance, remember that cosecant of theta, suppose it is given as some number x. Now we know that cosecant is the reciprocal of sine, so we can rewrite it as 1 over sine of theta, and it is still equal to this number x. Now if we're trying to find the angle theta, we need to get sine theta out of the denominator. We can't add, subtract, divide, or multiply by trig's functions. We can only apply their inverses, but we can multiply to get it out, the entire thing out of the denominator. We can't split up sine and theta. So we're going to multiply both sides of this by sine of theta, and we end up with 1 is equal to x times the sine of theta. Now again, we're still trying to find theta, so we are going to divide both sides by x, and this is going to give us that 1 over x is equal to sine theta. Now sine theta we can find the inverse of, because this is one of our buttons in the calculator. So we are going to take the sine inverse of 1 over x to get that angle. So when we have a reciprocal trig function given as a number and we want to find the angle, we need to take the inverse of the reciprocal of that number. So, for instance, if we want to find theta when secant is 6.05, we are going to first remember that secant is the reciprocal of cosine, so we are going to take cosine inverse, and then we are going to take the reciprocal of this number, 1 divided by 6.005. So if we go to our calculator, we are going to say second cosine to get cosine inverse of 1 divided by 6.005. We end up with an angle of about 80.4 degrees. Now we want to be very careful. This is not the same thing as actually taking the reciprocal of a given angle. This is taking the inverse of the reciprocal. So these next two examples are just a matter of plugging into the calculator to find our actual ratio. Notice that this says secant of an angle, this says secant of an angle equals a number. So we have to be very careful what it's asking for. So this first one we're trying to find the angle, the second one we are just trying to find the ratio. So again, we know that secant is the reciprocal of cosine, so we have 1 divided by cosine of 72 degrees, 27 minutes. So again, if we go to our calculator, we can say 1 divided by cosine. Again, this is not cosine inverse, this is the reciprocal. And we hit 72, we go to angle, we get our degree, then we have 27, we go back to angle, we get our minute, and we hit enter. And this tells us that we end up with a ratio of about 3.316. Again, this is the ratio of the sides of the triangle. So take a second here, pause the video, and try the next example to find the tangent of 52 degrees, 43 minutes, and 38 seconds. So again, be careful here. In this case, we can just put it directly into the calculator. Tangent is one of our functions. We don't have to worry about a reciprocal here. And again, remember that the seconds is above the plus sign if you're looking at a TI-83. So in this case, we end up with the tangent of 52 degrees, 43 minutes, and 38 seconds to be 1.314. And again, this is the ratio when we're looking at that angle. This is the ratio of the opposite to the adjacent sides. We have a few final examples here, and I want you to pause the video and see if you can find the angles. So this is working backwards. This is using the inverse. Anytime you see this phrase, find theta, you know that you're going to have to use an inverse. So pause the video now and find these two angles. So with this first example, you just have to simply do sine inverse. And then you want to again use that button, that DMS button, to get back to degree, minute, seconds. And you should end up with 58 degrees, 49 minutes, and 34 seconds. For example 24, you'd have to do tan inverse of the reciprocal because this was cotangent. And you end up with 12.511, or 12 degrees, 30 minutes, and 41 seconds. So this concludes the video for section 3.2. Please go online now and complete your homework for this section.